All right, welcome back. This is Kevin McCain with Idaho Art Classes and Kevin McCain Studios. So today we're going to talk about a little something called proportional measuring. So with proportional measuring, when we're drawing stuff, we'll take what we call proportional measurements. And all that means is that, let's say I had a square here. Okay. And let's say, for instance, that right there is actually a square. Okay. All right. So let's say this right here is actually a true square. And what proportional measuring says is that, or what the concept is that if this is a square, it's essentially, its proportion is 1 to 1. It should be as tall as it is wide. So if I took a measurement here, and I took a measurement here, it should be the same height to width. So that means that, again, that this is essentially 1 to 1. It's as tall as it is wide. And it wouldn't matter if this was a little square that was, ½ inch by ½ inch. It's probably closer to 3/4 of an inch, but anyways, if this is still the same as tall as it is wide, that means that this proportion on this little guy is still the same. So its proportion is still a 1 to 1. It's 3/4 to 3/4. Proportional measuring isn't by taking the measurement, it's taking the proportional measurement. So this is still a 1 to 1. So this is in the same proportion as this. Wouldn't matter if this was, well, in this case, maybe 3/4 of an inch. Wouldn't matter if it was 3 inches by 3 inches, or 10 feet by 10 feet, or 1 mile by 1 mile. A square is still a square, and its basic proportion is that it's as tall as it is wide, and therefore it's a 1 to 1 proportion. So if I measure something with my pencil by looking at it and measuring it, then this would be a 1 to 1 proportion. Okay. Now, again, if I went ahead and I measured something, again, we're going to do some citing for proportional measuring and stuff like that. And again, proportional measuring is just checking its basic height to width. And usually, not usually, but you always take the shortest side and you divide it into the longest side. So if this right here, if I stack two squares upon one another, so if I stack up two squares, like so, and these, and this is the square right here. This is a square. This looks a little taller than this one, so I'm going to check it. And I measure with my thumb and the top of my pencil, and my thumb and the top. Nope, it's the same. It may have opened up a little bit this way. This looks like it may have opened up a little bit that way. But for the most part, we have two squares. So this is also a 1 to 1. Now it hasn't gotten any wider. It's only gotten taller. So this is now a 2. 1 plus 1 is 2, right? At least in the mathematics I was taught at school. So this is a 2 to 1. Is the proportion of this rectangle. And it wouldn't matter if it was this small down here. So again, with proportion, we're not dealing with measurements. We're dealing with what is the proportion of the thing to itself. This is twice as wide as it is tall. This is also twice as wide as it is tall. These are in the same proportion. This is the same as that. And again, if we did a third square on top of here. Let's say we'll go ahead and place another square on top of here. I think you probably see where we're going on this thing. This right here, if it's again, if it's another square, we would then have a 3-to-1. Okay, so when we're drawing objects, to get a better sense of what it is we're drawing, so I pushed that line right there, right? I established the line, but I have said in drawing lines it's easier to pull line. Now I'm a lefty, which means I pull to my left. If you're a righty, you pull to your right. But now we have another 1-to-1, and it hasn't gotten any wider, so this is now going to be 3-to-1. Maybe I'll write this up here, make sure we can see it. But this is 3, 1, 2, 3. This is still the same width, so it's a 3-to-1 rectangle. Okay. And when we're dealing with stuff, we're going to start to be very, very interested in what kind of rectangle we are looking at. Because we're, just in case we were running out of room, this is now a 3-to-1 rectangle. If we did this, well, we divided this in half. So now if we had something that was in a rectangle like this, this would now, whoops, that was wrong. Let's get that little, there, that's still a little off. About right there is closer. About right there is closer. About right here is closer. But if we said, all right, well, all of a sudden, this right here is our rectangle. Like so. Well, then this rectangle here, if this is 1, and this would be 1, 2, 3, 4, 5, 6. So if I used, so let's say, for some reason, let's say we cut this down, but I'm just showing you that this would be what a 1x6 rectangle would look like. Right through there. This would be right here, would be a 6x1 rectangle. Okay, now, so again, just this part right here. Look how skinny a rectangle that is. And so the whole point of this is to figure out what kind of rectangle does the object sit in. Okay, is it a 3-to-1? Is it a 6-to-1? And that's why we measure, is to figure that out, and then we can draw it, and we can draw it much better if we know the rectangle the object fits with inside. So again, if this was, again, it doesn't matter the size. If this is, again, if it was this small, like so, this right here would also be a 6-to-1. So this rectangle here and this rectangle here are in the exact same proportion. Okay, so it doesn't matter how big we stretch this or how small we make it, it should always be a 6-to-1. So if we had somebody that we were drawing, and this person we were drawing was, well, people are 8 heads tall, for the most part, is their basic proportion, if they're a full-grown adult. Some people will say 7.5, some people say 8.5, but 8 is usually the most common. It doesn't matter if you shrink that person down super small or or make them really big, just make that a really big picture. It's always, a 1 to 8 rectangle that you'd fit that person's height in. Now that's actually not quite right, because actually a person usually is 2 increments wide, so you'd actually turn it into a 2 by 8, but we're not going to worry about that. So it'd be 8 heads tall and then 2 heads wide. So anyways. So we're not going to get into that, but I'm just saying it's the same proportion. And we could do the same thing with this. If we wanted to, we could make it smaller. We could also make it bigger, but it's really easy to do this. All we'll do is we'll come down here, look to where I'm drawing, and we're going to make a diagonal. And there's a law that says if, now this is bending a little bit, should actually go through the middle, which should be right about there as far as that goes. If this right here is in the middle, that's where that should touch. And it is in the middle, so that just means this diagonal, I lost it a little bit. That's all right. Go through that point, come down. Now we have a diagonal. It's pretty close to being. It's not amazingly straight, but it's straight. If I took the diagonal, this is the diagonal of this 1 to 3. Ignore this little guy in here for now. For it to be using this rectangle, it'd have to be a diagonal from this corner down to there. I wanted it a little bit wider so you could see it, so I used this corner, coming down through the middle, down to that corner right there. Okay, so this is the diagonal for the 1 to 3 rectangle, and that's just important that you understand that that's what we're doing. We're not trying to make this meanders a little bit down through there, but anyways, we'll just say that's straight. We'll use our imagination, shall we? But the cool thing is that if I take any 2 lines that meet at 90 degrees, that meet and hit that diagonal, and that's 90 degrees, and I bring this straight down. Whoops, that's coming in way, way too far. That's a little closer, a little better. Again, not perfect, but if we want to, we could get out our handy dandy little triangle here, and we go, well, let's straighten this out, shall we? Let's make that look all pretty. But if we want to, we can make this one prettier too. Make it look good. Like so. And again, if it touches that diagonal, and these are 90, and that's a 90 degree angle, what this means is that this rectangle that I've drawn is the same proportion as this rectangle, because it shares the diagonal and it touches that diagonal with a corner. The corner is 90 degrees. So in theory, theory's always fun. I like theory. Theory is kind of a cool thing. If we went ahead and we could make this, we could just make it anywhere as long as it conforms to what we just talked about. Well, then this right here, again, as long as it's 90 degrees, meets at that diagonal at 90 degrees, this rectangle is the same proportion as that rectangle, the same proportion as this rectangle. Hopefully you can see that. But this is what's really kind of cool, is again, we're talking about the proportions. That if I took this rectangle, wherever it's at, that's not quite 90 degrees, that's opening up. There we go, that's a little better. So again, if this is hitting here, and this is at a 90 degree angle, well then, and this is the 1 to 3, let's not forget that, I should be able to measure this length, and it will divide this into a 1 to 3 rectangle. Okay, and it does. Okay, so again, we could start over here. We say, hey, what's that? What's the width? And we say, well, this is the width right here. And we say, all right, well, that's the width. And if it's still in proportion, it should divide it into 3 parts. 1, 2. Whoops, missed it. And use this to mark this off. It's going to be pretty close. Is this going to be exact? No, but it's going to be very, very, very close. So again, if we mark this, mark that, and then mark this, that's a 3-to-1 rectangle. And if we did the same thing here, now this seems to be coming in, so that means it's not quite 90 degrees. So we'd have to, again, we have to make this line straighter. Now, is this going to be perfect when I'm drawing this? No. I'm using like a drafting tool right now. But still, all we've done is we've moved this out just a little bit, and it should still be enough that it should be close enough that if I go ahead and measure this and divide it, it's going to be 1, that's 2, and that's 3. That's a 3-to-1 rectangle. So it's really kind of cool. Proportional measuring. And so that's what proportional measuring is. First of all, take the measurement and we'll measure the whoops, that's not good. Something got out of square. There we go. But you'll measure what the object is, and then you'll make the rectangle. Now again, it doesn't matter how big my square is, it's just the square has to be a 1-to-1. So this is my square, and I did a 3-to-1. This right here, well, this right here would be a 3-to-1 rectangle. And if I was doing a bigger drawing, well, then I could, and I wanted something bigger, I'd start with the square becomes what we call our increment. And so if I was dealing with my square here, and this was my increment, well, then I could just go, okay, and I'll take this measurement and I'll make it 2 more. That's 1, that's 2. Again, whoops, missed it a little bit. Yeah, it's about there. So, and then we could just draw this by hand. Now again, is this going to be a perfect rectangle if I'm drawing it by hand? No. The more I draw rectangles, the easier it can become, to be sure. But, you know, this is to give us a basic rectangle. We're not trying to do a drafting sort of a drawing, but we do want something that gives a nod to the proportion of the object that we are drawing. Okay, so again, a 3-to-1 rectangle. Now sometimes we have something that's just a 2-to-1. Sometimes we're going to have stuff that's a 6-to-1. I have my students draw an ice wine bottle that we have here in class. And it's about a 5.5-to-1, which is the next part. What if I have something that's like a 2.5? Well, then we use armature of the rectangle. That's on I teach about that as well. And with the armature, we can go ahead and take if we take any, oops, that's a little off. That's better. Missed it a little bit, but I'm pretty sure that's going to be pretty close. But again, if we moved it, it's only going to move this by maybe a 64th of an inch. So for all intents and purposes, that's pretty dang close. So this would be the middle, because if we use X marks the spot, and if we want to clean this up so we can actually see it, you know, you're like, all right, well, I've already done it by hand. We can now go ahead and do it, you know, straighten that line up a little bit with our cute little triangle. And again, was it perfect? No, but look where I was. I was, you know, right in the, and you know, I was in the ballpark. But we divided this into half, so this is now a 1-to-1 and 1/2-to-1, and so this would be a 2.5-to-1 rectangle if we are only, you know, we'd erase this back off and we'd only use this, right? And if you know how to use the armature, we can divide this in half, we can divide it into quarters, we can divide it into 6ths and 8ths and 9ths and all kinds of fun stuff, 16ths if we wanted to, but we're not going to go to that extreme when we're drawing objects. Normally we're not going any further than thirds and quarters, or 2/3, you know, or 1/4, 1/2, or 3/4. That's usually as far as we'll take it, and then we'll you can guesstimate from there, because that'll again have you in the right ballpark. Usually when we just eyeball it, we're nowhere near the ballpark. We're down the street. Sometimes we ain't even within a mile of the park. So again, we're going to go ahead and use proportional measuring. So the first thing we do is measure, and then this is how we use the measuring. So again, if I had an object in here that's a 2.5 to 1, and I have a bottle that is sort of a 2.5 to 1, then we could go ahead and put in the center line, and we could draw that bottle as far as that went. Okay, all right, well, that's my object. Okay, that's fine. And then we had the bottle we're going to use, and the bottle is I think the bottle is actually 2 1/4, so this would be a little too thin. But I have a bottle that we use that is sort of it's a custom beer bottle or something like that, and it has a real clunky sort of body down here, and then it has on the top it's got a neck, and the neck kind of comes in like so, with a little S curve like this, and it's kind of funny because it almost looks like a crane that swallowed an egg or something, because there's like it comes up and then it gets a little wider and then comes in. So it has like a little bulge in the middle of it that always reminds me again of like a blue heron swallowing an egg or something. So we have something like this, and then we come up here, and then the bottle has now this is just a flat silhouette. We're not putting on ellipses, we're not doing any of that sort of thing. And then this comes up like this, like so. It gets a little wider. This would be where it's and it has like a little, it's one of these, it's got like a spring top. It has like a little clamp that, like the old canning jars. So it's kind of a funky thing that someone gave me. To me it looks very very retro, or very old-fashioned, sort of turn of the 20th century sort of way of keeping beer in bottles by using a little clamp on top. So anyways, this would be, and again, if we had something else next to it that was a 3 to 1, again we would, or maybe even a 4 to 1. Okay, well, some next to it is a 4 to 1. Well, if this again is, nope, that's not as tall as it is wide. Let's go to our first increment, and I think we got lost in the first increment. So we're going to go from here, because I know that has the corner, that has the corner. Take that increment measurement, bring it up. Oh, it's close. Wasn't great. It wasn't close. Or I was close, but anyways. If we had something next to it that is a 3 to 1, well, wait, actually this is 2.5. That's 3. Okay, 4 to 1. Sorry. So this was the original point of 3, and this one's 4. And so if we said, all right, well, if this is next to this, like so, and this one right here, which isn't even close, like so, and this is again this is a kind of up here, and it has to be the same width, because to use this proportion we were using the increment, the square, and so it has to be the same width. All right. Whoops, that's opening up. Bending a little bit. This is kind of, I'm a lefty, this is getting way to the right, so I'm going to go ahead and use this. I kind of have to bend my arm, kind of weird to get in here anyway, so the more it pushes to the right, the worse it gets. So let's just say this right here is my rectangle for my object. And I have other bottles in here that are wine bottles and things. And you know, I do have a few that are, again, a 4-to-1, where you'd have, this would be the sort of the body of the wine bottle. We could go ahead, if we're drawing something symmetrical, we need a center line. So again, we'd use the armature, X marks the spot for that. So we could say, all right, well, is this the middle? And if I needed to check it, again, I've got this one right next to me, and I'd say, well, I was close. I was within just under 3/16 of an inch. No, not 3/16. Pardon me, 3/32. It was just under, just about an eighth. So this is the actual middle. This is where I hit by doing it freehand. So again, you're in the ballpark. You weren't in the stands, but you were, you know, getting the tickets. And then we double check to make sure that this is in the middle that way. So we can go ahead and measure this with my thumb and the end of the pencil. And if I have a hard time seeing because that's a dull end, then we can use this. It has a very good, you know, edge on it, and we can go ahead and let's see, is that the same as that? And if it's not, then, and again, I've got this one right here, I can double check this way. Well, that should be the same distance, and that's, so this was the one that's sort of the more offending of the two. Again, I've got this little, I did X marks the spot, cleaned that up really well, and that's, again, pretty close. Well, then we can say, all right, and I could just double check to make sure that this is, you know, here and that's there. Looks like it's close, but again, but we'll just say, all right, well, this right here is my center line. Once I decide where the center line is, all guesswork is off the table, because that now becomes my center line no matter what, and I would square everything up to that. So again, try to get this nice and straight. I can't tell because it's so far to the right of me, but let's just hope that's a straight line. We'll use our imagination, shall we? And again, I think we'll find, you know, this is pretty close, one side to the other. If I again took this and go to this, again, we're pretty close. So again, if I had another wine bottle like this, that's a 4-to-1, well, then we're going to have, basically, wine bottles are very simple. Even the complex ones are not all that complicated. They're usually rectangles sitting on top of a circle sitting on top of a rectangle. But again, this would then be the shoulder. We wanted to get into that whole circle on a rectangle thing. And then this is right here. This would be the body. Now this is a simple silhouette. We don't have any of the ellipses on here. We don't have, you know, any of the labels or any of the complex stuff. We just have the simplicity of the basic proportion, outside proportions of the height to the width, which is what we wanted. This right here again. Basic silhouette of a wine bottle. Okay, and this is a particular wine bottle. So again, I might have some wine bottles that are a little taller, some a little less tall. I talked about the ice wine bottle that I have that's really skinny, and it's like a 5.5-to-1. This is a 4-to-1. So again, all your rectangles will give you a much different look because they're all different proportions. So again, proportional measuring is to give us the width versus the height, and we use the increment of the square to then define it, subdivide it when we need to, and draw it. And so first we do the measuring. We do you know, seen people do this where they're looking at stuff and sighting down their pencil, and that's for the measuring part. And then once you've got your measurement, oh, it's a 2-to-1, or no, it's a 3-to-1, or it's a 4-to-1, or maybe it's 3.5. You would start your drawing by deciding, okay, how big do I want my bottle? If this is a 3-to-1, well, that's a real tiny bottle. Well, this was also a 3-to-1. Well, that's nice. Maybe I only want it at this size. Again, you need to start thinking about where to put it and how big to make it and all that good stuff. But these are the ideas of proportional measuring. So we're going to go ahead and we'll talk about some more aspects of measuring and how to use it and all that good stuff. But let's talk about other ideas and concepts to the measuring, how to use it, how to draw with it. But this is the idea of, the stacking and what is the width to the height ratio. That's what this stuff is all about, how we use it. All right, so you guys have yourselves a great day. Be more creative. Take care now. Bye-bye.